G'day, howdy, hi, welcome to the show. This week I wanted to actually talk about batteries, a pretty important part to building your projects and finding the right power source. Virtually everything these days, portable devices and so on have batteries in them. A lot of them come with lithium, but they're not the only choices. So I thought I'd go through a lot of the battery options that you can have for projects this week and cover off on battery technology, charging options, and things that you can actually use in your projects. Before I get going, I've been working on this, what I was going to call a Raspberry Pi Portable for a while, but actually we'll probably end up going for either the Raspberry Pi 2 or the Banana Pi as the brains, as the actual computer for the portable device that I want to build. So as you can see here, just using the composite connection out of the Raspberry Pi into this little driver board, I've got this 7-inch LCD, and it's not too bad. The size is pretty decent for what I'm probably trying to achieve. This particular one, I covered this off on a couple of weeks ago. This particular one's got a little board with a remote to actually change your selection for your inputs, so your composite, your VGA and your HDMI. This one's low resolution, it's about 720 by 500, 400-ish. And it's not too bad, it'll do the job. But I wanted to keep most of the inputs on this board, and my train of thought at the moment is, okay, I've got the Raspberry Pi or the Banana Pi equivalent, size-wise there's not much difference. I've got this little controller board, I've got this 7-inch little LCD, which requires 12-volt power with the actual board as well, and I wanted to keep all of the board, have multiple options for inputs. Power supply for the Raspberry Pi, power supply, all portable, power supply for that, power supply for this, and then I've got this little eBay type keyboard. It's actually got a little bit of depth to it, but the keys are actually not too bad, and you've got this little touchpad option here as well. So I did pull this one down, and it normally has a 3.7 volt lithium ion battery as well. So that could be removed from the device, but then you're talking about bulk and size and other problems. So when I had a look inside this one, it's all pretty good. That is the, just in there, that is the connection for the 3.7 volt lithium battery. You can see the terminals on the bottom. So that option there's your little 5 volt USB input, that is power only, and this is a Bluetooth. You can actually see the Bluetooth antenna just there. So this is a battery powered option only. You can't quite get this to run off the mini USB connection as the communications. It's only for the power. So as I pulled this one down, don't remember it being this hard to do. There are some clips in there. There we go. So it's a pretty simple board. That's the entire keyboard, very thin aside from the lithium ion battery connector. Not many components, all on board, little domes. There's your touchpad, and obviously the membrane comes off. I'll pull that out in a minute, but the membrane comes off. And so even if I leave those together using the frame, that is a fairly thin little option without the backing and without the lithium ion battery sticking out, apart from this part. It's a fairly thin little option to be able to start stacking parts together and building myself a portable Banana Pi, Raspberry Pi, whatever it ends up being. But just a bit wary of the bulk. Obviously I wanted this to be something that's portable. I didn't end up wanting it to turn into a netbook or anything like that. So I'll keep working on this one. All the parts are here except for my two dedicated power supply modules, and then I need to think about a case and how it's all actually going to come together without sacrificing some of the components and some of the options I want it to keep. But also I don't want it to be 4 inches thick. So I'll keep working on that one. But as I was working on that, and what brought me about for this week's episode, is the batteries. So the little keyboard came with a 3.7 lithium battery. The teardown I did for the MEHS a couple of weeks back had obviously 3.7 volt lithium ion batteries in them, and a little charging circuit and so on. So what have we really got in regards to batteries? What are the differences between the batteries? What are good choices? What are easy choices? What are hard choices? How hard is it to actually charge them? For this particular project, what I wanted to get to was the laptop type approach. Plug an external power supply in. By plugging it in, that provides power to your project, your Raspberry Pi or your Banana Pi, and your screen and any other peripherals. It also charges whatever batteries you've got in there, whether it's a single 3.7 battery pack or something else. That's the kind of approach I wanted, and that by itself brings in a few challenges. So let's start by having a look at a few batteries, a little bit of the differences between basic battery options, and then we'll get to talking about the charging of 3.7 lithium batteries and charging of a few other different types of chemistry batteries. Okay, I've got a bit of a collection of batteries here, and we'll just go through these fairly quickly because these are the typical kind of batteries that you'll come across for your projects, or at least choices from the local store or from wherever. So your everyday AA, no big surprise there, AA battery. The chemistry of the battery is nearly always written on it. So you will find that this Vata long life, right, AA, all AA's are the same as far as the alkaline variety go. So you will see written on the bottom there of the battery fairly clearly, this is an alkaline battery, and you will see the voltage written down in here, 1.5 volts. Yeah, so 1.5 volt alkaline AA battery. Now that's a disposable type battery, although you can actually get chargers that will put half a dozen chargers back into these. So surprisingly enough, your disposable AA battery, if you didn't already know, can actually be recharged properly a few times with the right charger. So yeah, have a look at that yourself. There are charging options available for those if you think it's worth your while. So moving on. Okay, so this is a rechargeable battery, and you can see NiCad is the chemistry, AA is the size, 1.2 volts. So it's a 1.2 volt option out of a NiCad rechargeable battery. Nearly all rechargeable AA batteries come in 1.2 volts. Put that aside. Here is a nickel metal hydride equivalent of a AA. So 2400 milliamps is the capacity, so 2.4 amp hours at 1.2 volts for the AA battery, and charge up to 1,000 cycles. These are all mostly the same. Some are better than others. It just depends on realistically what you pay for. And the voltage is marked towards the top there. Hopefully comes at through 1.2 volts. So the only real major difference in the AA nickel metal hydride equivalents is these new any-loop type batteries. I think they're a Panasonic. These are still 1.2 volts. So here we go, 1.2 volt battery, 1900 milliamp hours. It's a little bit less than the PowerTech one I had a minute ago at 2400 milliamp hours. The difference with these ones, they are more expensive, by the way, quite a bit more expensive. The difference with these ones as opposed to a nickel metal hydride such as the old PowerTech, when you put a PowerTech on the shelf, charge it up, put it back in your cupboard or wherever for use later on, this will start to go flat fairly quickly. And after about 3 weeks, realistically, it's got maybe 10%, 15% of its life left in it. So it's for useful purposes, it's flat. So they last about 2 to 3 weeks in the cupboard. Some will be better than others. And that's typical for nickel metal hydride technology. Your alkalines, your typical disposables, they'll last years, up to 10 years shelf life before they lose their charge. It will very slowly degrade. So even after a year, you're still talking 90-95% capacity. These, in the nickel metal hydride chemistry, typically go flat, like I said, these ones about 3 weeks, but these will actually hold their charge for up to a year, I think it is. So they are excellent for charging up and putting away and having a ready power supply, a ready power source, typical to a disposable battery. But these ones, rechargeable nickel metal hydride technology or chemistry, and will hold their charge for a very long time. I think it's possibly actually more than a year. So they are an excellent option. However, when you're going to use these in your projects, they have a more regimented recharging procedure that you have to go through. So these have a more regimented recharging procedure than a typical nickel metal hydride battery, in order to be able to ensure that you're staying safe, you don't blow them up, you don't cause a fire, etc., which you can do in recharging batteries. So these ones, excellent choice, even for a project, something portable, but you really need to be careful about the way you recharge these. Okay, so this is just a AAA variant of a AA battery, same voltage, 1.2 volts, and reduced capacity simply because of the physical size is a lot less. This is a 900 milliamp hour battery. A disposable version of a AA, again back up to 1.5 volts, not 1.2, so all the disposables typically 1.5, and yep, we've covered those before. So what else is there? Well, you've got this type of more specific battery. These will tell you again the battery chemistry. So in this instance we're talking, this is an alkaline battery, and the alkaline battery has a voltage of, as you work your way around, 1.5 volts. So this is a 1.5 volt alkaline battery, disposable. This one almost the same size, and this one's the A23. But this is kind of handy in some projects when you need a bit more power, because this one's actually still alkaline, but it's 12 volts. It's a 12 volt power supply. So a couple of those in parallel. The capacity is not great, but if you haven't got a really hungry device, it doesn't need a lot of amps, but it does need 12 volts, they can actually be a decent little option. These are lithium in chemistry, but disposable, not rechargeable, and 1.5 volts is your typical button battery value. And some batteries are actually made up of these just stacked. So one on top of another, and so on. So you're running them in series to build up a higher voltage. Right? Even this little 12 volt equivalent, if I pulled this one down, it would probably find that it's a series of little buttony type batteries stacked on top of one another to make this up to 12 volts. So they're your typical little button type, many different shapes and sizes for those, or different sizes anyway. And then you've got these. Now you'll find a lot of high-powered torches and some other devices use these kind of batteries. They're an 18650, clearly marked on the side. 18650 battery. This one says it's a 4 amp hour battery. Let's get a bit closer there. So as you can see, they look like a AA, but they're considerably larger, both in height and in width. They're an 18650, and this one, like I said, rated at 4,000 milliamp hours or 4 amps at 3.7 volts lithium ion technology. So this is a rechargeable battery and does hold quite a decent capacity. If you take that as an example, 3.7 volts lithium ion, 4 amp hours. This little battery, this is the one that actually came out of the keyboard that I showed you a minute ago. This little one here is 3.7 volts, 810 milliamp hours. So 3.7 volts, 810 milliamp hours, as opposed to 3.7 volts, 4 amp hours. So 810 milliamp hours, 4,000 milliamp hours. So, you know, 5 times the capacity, if that's a true rating, and I don't believe it actually is. It's probably more like 2.8 to 3, but anyway, we'll leave that one alone. And this one a much more expensive version of this. Looks exactly the same. It's called an 18650. So here we go again, 18650 type battery, 3.6 volts, lithium ion rechargeable, protected. Now what does that mean? Well, if you looked at these two batteries side by side width-wise, you probably wouldn't measure any difference. The difference is actually in the length. So if you take a really close look, I'll put these on the bench. So what you can see there is that if I set them up, touching that battery, you can see that up the end here, right, so up this end here, this battery is longer than this battery. And that is because this one, as it said on the label, this is protected. So it has a protection circuit just at the end of the battery, right, making it slightly longer than this one. And that protection circuit is the reverse polarity protection. So there's nothing stopping you putting this in the wrong way, into a device, into a circuit, and potentially making a big mess. This one will not function if you put it in the wrong way, wrong polarity. So that's great because these actually contain quite a decent amount of oomph. So if you want to swell a battery, blow it, start a fire potentially, these are a good battery to do that. When they're protected, you don't have that option. So when you pop these into an 18650 battery charger, and yes, you do need to use a proper battery charger. So with these, the unprotected battery, put it in the right way, makes a connection, starts charging the battery, reads the voltage and so on and so forth, and goes through the proper graph, the proper procedure for charging one of those. With these ones, mostly the same thing happens, but what you can actually get into is a situation whereby it doesn't acknowledge the battery, and that's because of the battery polarity protection. So all you do then is you disconnect it for about a second, maybe 3 if you want to be certain, and then reconnect it, and it lets that reverse polarity circuitry reset itself. But they are an absolutely fantastic battery, and when they say 3400 milliamp hours, it's pretty damn true. It's pretty close to the mark. Some of these other batteries, I'm not commenting on the brands, I don't know what factories they're actually coming from, but when they say 4000 milliamp hours, my experience is it's about 3/4 of that. So in this case, I'll probably say it's more like a 3000 milliamp hour battery. That's still a lot of juice for a project. So as we've covered off on these 18650s, and they're fantastic, and we've got these typical little 3.7 volt lithium ion batteries in the flat packages, and these can come incredibly thin. So these are pretty much, these ones here are pretty much all the same. They're all lithium ion, they're all 3.7 volt. There's just differences in the packaging. So this one here, I think this is out of a Kindle, and you can see that there are different terminals and different connections for the battery. That just simply means that there's a bit more, potentially a bit more circuitry in a package like this, and there's the ability to read sometimes the charge conditioning or the charge rate of the battery as well as the temperature. So that's all those extra terminals do. But in essence, this is the same as this, is the same as these two here. They are just 3.7 volt lithium ion battery packs, just the difference in the shape. That is also exactly the same. It is a 3.7 volt lithium ion battery in a different package. In this case, it's an 18650 package. So these are fantastic for your projects, more so than any of these equivalents. One, because of their capacity. So you get great capacity out of the lithium ion batteries that are available at the moment, and they're light, and because of this flat type packaging, you can put them into your project without building a lot of bulk. You can also use these, and I was thinking about using these for the Raspberry Pi Banana Pi portable that I want to make, but they do have some bulk to them. However, you do get, again, really good capacity. So it just depends on your purpose. The issue that I'm coming up with at the moment is regarding these 3.7 volt battery packs. And like I said, this is this one here is a 2 amp hour battery, so half the capacity theoretically of this 18650. And what the trick is when you're going to run a project such as the Raspberry Pi or the Banana Pi portable that I'm making, the LCD, so the LCD and the driver board for the LCD are 12 volt, so there's a 12 volt power requirement for those. The Banana Pi, Raspberry Pi, they're 5 volt. Now it's 5 volt at 2 amps, and this is 12 volt actually at 0.3 of an amp, so it's pretty good on power. So you need to be able to power your device. So then we get into the situation of what am I doing? How am I getting 5 volts to the Banana Pi or Raspberry Pi? How am I getting 12 volts to the LCD and driver board to run those from a 3.7 volt power supply like we've got in front of us here? Well, one of the easier ways to do it is get closer to the 2 voltages. So you've got 5 volts for one and 12 volts for another. You can get up to 7.4 volts by putting 2 batteries in series. So if I ran these two as an example, like that, as you would see in many little torches, you just pop your AA's or your C cells in one behind another, you end up with this configuration here. And if I tapped off the end of that, I can actually get 7.4 volts. So that's much closer to 5 and 12, and I don't have to do as much work or lose as much energy in doing the conversions to get 12 volts and 5 volts. So power regulation. So as you'll probably remember from the Mophie teardown, there was a 3.7 volt battery in those and a little charging circuit that had a micro USB connector for the 5 volts in. So this little module here was taking 5 volts in through the micro USB, providing power to a connector which has been removed, and that was a phone, so that was providing 5 volts through to the phone, 5 volts in, 5 volts through to the phone, and then using the right charging methodology and circuitry, it was providing power to a 3.7 volt lithium ion battery. So when 5 volts was plugged in, it would power the device and recharge the battery. That's exactly what we're after, that kind of approach. External power comes through. When the external power is connected, it powers the device, and the power is then put through and recharges the battery, but the battery doesn't need to be drawn upon to run the device whilst the external power is connected. So that's great, and that is easy when you're talking about one 3.7 volt battery. There's heaps of 3.7 volt charging circuits. Don't just apply power and assume you can charge one of these. You can't. The 3.7 volt lithium ion battery, the recharging requirements for those, it's a 3-stage charge, and there is a voltage stage as well as a current stage, and the tolerances are about 1%. So don't try and knock something up quickly. You need to do quite a bit of research if you're going to make your own 3.7 volt lithium ion charger. To get that wrong, the battery will swell, potentially burst. When exposed to air, you're pretty much talking a fire. So if you're going to make your own, do your homework, please. So anyway, 3.7 volts, using something like this little charging circuitry here, right? That's not too difficult because, like I said, there's lots and lots of choices for 3.7 volt charging circuits. But what about getting more power using something like 2 of these and getting a 7.4 volt option? How do you charge that when it's in a device connected permanently at 7.4 volts? Well, that's a bit trickier. There's not a lot of choices there. At least nothing I've been able to find to be able to pull together a charging circuit quickly and easily. However, I have come across 2 options. I will need to make the circuit myself if I want to go for a 7.4 volt option. So let's take a look at the moment at what I'm looking at for my Raspberry Pi or Banana Pi portable device and how I'm thinking about powering that. So I've got the iCircuit software, and I've got a little bit of a design thrown together about the portable device that I want to make using that 7-inch LCD, the driver board, and some sort of device like a Raspberry Pi or a Banana Pi. So The idea is I'll have an external 12 volt power supply, and I'll have the internal power supply, probably a 7.4 volt supply at this stage, but possibly still a 3.7 volt single cell like this one. And there are a couple of different choices with these too. You can get 3.7 volt equivalents with higher capacity because they sandwich them together. They're still 3.7 volts and you charge them as a 3.7 volt battery. But because they're a matched battery, they can stack multiple cells together and still make a single 3.7 volt battery with a much higher capacity. But for my purposes, single 3.7 volt, probably even this one, the 2 amp hour battery that I've recovered, right, or multiple 18650s to get 7.4 volts. So 3.7 volts, 2 amp hours. If I use that in my project, I'll probably get an hour of use. So whether an hour of use or not is enough, yeah, I'll have to work that part out. But the circuit for the most part, 12 volts external, so this will be a plug pack or a wall wart, giving me 12 volts coming into the device. I'll have some sort of little LED running to be able to denote that I've got external power fully connected. The external power will come through the circuit and run the 2 power regulators. So I've got 7805s denoted in this diagram, but they probably end up this might be a 7805, but the 12 volt power supply for the LCD, that won't be a 7805. So either way, I'll have 2 power regulators for the external devices, the Raspberry Pi and the LCD. So 12 volts in, and that will provide power to the power regulators. The 12 volts in will also come across here to another, this won't be a 7805 again, this will be a charging circuit, something similar to this little job here. So this particular charging circuit will power either a 7.4 volt dual 18650 battery power supply, or a 3.7 volt single lithium ion power supply. Haven't worked out which yet. So either way, this charging module will provide charge to the battery pack, and I'll have probably a MOSFET due to the power requirements. I'll have a MOSFET running in this section here, which when 12 volt going through to the base, it will shut down the 7.4 or 3.7 volts going into the circuit, and when you do not have 7.4 volts going in, you'll basically have a connection there. So no 12 volt power supply, the 7.4 or 3.7 volt will power the screen and the computer, Raspberry Pi, Banana Pi. So that's the rough circuit that I'm coming up with. Still needs some more work, but the power supply issue is the bigger issue at the moment, and that's why we're talking about the battery technologies and charging options that we've got at the moment. Okay, so that is the tricky part regarding powering something like this design, the Raspberry Pi Portable, Banana Pi Portable. So whether I go for a 7.4 volt supply or a 3.7 volt supply, I haven't figured that part out yet. I have found 2 rather good modules. There's a Texas Instruments and a microchip product. I'll put those up on the screen now. So the Texas Instrument and the microchip product are able to charge a dual cell, so single or dual cell lithium battery. So if you've got 7.4 volts running in your project, they will actually provide enough current and properly charge 2 batteries in series, giving you a 7.4 volt power supply, and the charge rates, I think it's 8.4 volts. But again, it has all of that proper measuring circuitry, the testing circuitry, the proper voltage supply, then the drop off in the current. It charges the battery properly. So that's what I'm looking at the moment. I might have to actually design my own little 7.4 volt dual cell circuit to go into this particular project, and if that's just becoming too difficult, or I'm just running out of time, which is usually what kills me, running out of time, I might end up going with a simple 3.7 volt supply. If that's the case, I'll have limited capacity, 0.3 of an amp draw from the LCD, running off HDMI anyway, So 0.3 of an amp draw at 12 volts, 2 amp draw from the computer, possibly 2.5 amp draw if I plug peripherals in. So 2.5 amps at 5 volts. I've got a decent amount of power being drawn, so the battery is important. So just need to figure out whether it's a single cell or a dual cell, and if it's a dual cell, need to look at the microchip or the Texas Instruments options and make a proper charging circuit for a dual cell lithium ion power supply. It would be pretty handy for projects in the future. So thanks very much for joining me and watching the show. Subscribers are always welcome, so feel free to subscribe, that would be great. And I hope you'll join me again next week.